So APT version 2024.5.2 is the latest version of APT that is available. And that is the version that you should use to prepare your cycle for JWST proposal. Any later version is also acceptable if a new one is released. If you want to see a list of everything that's new for APT, for JWST, you want to click on the What's New button at the top right of the APT GUI. You'll be taken to a web page with notes on what is new for each version of APT. And I'm actually going to demo that. So this is the What's New button here. If you click on that button, it will take you to a web page that shows you everything that's new for APT releases. This will show you HST, Roman, and JWST, unless you have loaded some proposal that's telling APT that you are using JWST. So if you get to this page, you want to click on this link here, What's New for JWST, and that will take you to this page, which will be the page that you get if you've already loaded a JWST proposal, and you click on that button. It shows you all the things that are new based on the release version. To go all the way back to the call for proposals for cycle 3, you want to go all the way back to APT 2023.7.1. So I've listed that in the slide here in case you can download the slides later for that information. And I encourage you to go ahead and click on this button and read through all the changes, because I'm not going to cover all of the changes. The changes that I'm going to cover in this demo are listed on the next 2 slides, which I'm not going to leave up because I'm going to be demoing things in APT. But these slides are available if you want to download them later. And this is just a copy of what's on the new things that are new page, the web page. And you'll notice that some of them do have links to further information. So you can click on some of these articles to get more information on how to use the capability or what kinds of things you need to know. So I'm going to stop that and start my demo here. I'm going to open a file, APT file that has some observations already defined so that I can show you some of these capabilities. The first topic that I want to talk about is in the nearest AMI template. You can now choose direct imaging based on filter instead of doing all of the filters or none of the filters. And you can see that down here. You can click on which filters that you want to have a direct image for. So if you want all of them, you would need to click all of them. If you want none of them, you can leave them all unclicked. But if you only want 1 or 2 to save time, you only need to click on the ones that you want. And then all you need to do is enter the information for the direct image and you're all set. The second thing I want to talk about is proper motion. Proper motion is very important for templates and apertures that are very small, slits, spectroscopy, coronography, and things like that, including this AMI template. So you'll notice the target that I'm using here is called AM target. So if I expand and look at that target, you'll see that I have checked the button that says negligible or not applicable next to proper motion. And that tells the system that, yes, I thought about proper motion, and yes, I really mean to put in that it is 0 or not applicable. If I go back to this observation and I choose to look at a target that has no proper motion, you'll see that an error has popped up here on this target. Now, it didn't have an error before because it wasn't being used in an observation that had a very small aperture. So all I need to do is enter the units and the values for my proper motion, including an epoch. Or I could just have clicked this negligible or not applicable button like you saw on the previous target. That way, back to the way it was. The next change I'm going to talk about is in the MIRI coronography offset target acquisition. So I'm going to go to my MIRI coronography example. It used to be, I believe, that you needed to do your target acquisition on your science target. Now you can do it on a nearby target. So the target for the science is specified up here under target, but in the target acquisition parameters, you can either choose your science target or you can choose a nearby target. All of the offsets will be done automatically if you choose the offset target from your offset target to your science target. The next change I'm going to talk about is in the NearCam GRISM time series template. Here's my NearCam time series template observation. And in previous cycles, you were only allowed to choose imaging for your short wavelength channel. But now you'll see that you can, in fact, choose GRISM. When you choose a GRISM, the parameters that you're able to choose for your GRISM time series do change. But both options are now available, and they were not before. And I believe this was long awaited. The next change I'm going to talk about is in Aladdin, and it's for moving targets. Now, this is sort of a time of observation tool in the sense that you would probably only be running this tool to look at the position of your moving target based on the background, with respect to the background sky, when you're really preparing to have your observations taken. So it turns out that this tool can only be used if your proposal has been submitted at least once. It does not need to be accepted, but it does need to be submitted at least once. So what you do is you go to your moving target observation, you go to the solar system panel, and you click generate new ephemeris. It has a start time, an end time, and a step size. And you want to make sure that these times are fairly close together. So I'm going to pick June 29th of 2025 and July 1st of 2025. You can also type into the box if you don't want to use the calendar picker. And I'm going to use a step size of 12 hours. That should give me 5 points for these days, 1 at the beginning, 1 at the end, and 3 in the middle. I hit generate. If the generate button is grayed out, just click somewhere in the box and the generate button should turn black for you. Once the ephemeris has generated, you can view the ephemeris data here. You can see the times that it's and dates that it's giving you this information, along with an actual number readout of the position and the distance of the target. That may not be very helpful, however. You may want to view it in Aladdin. So you click View in Aladdin, and you can see my apertures are already up here. I'm going to load the digital sky survey. And now you can see where your apertures would be on each of the 5 step sizes that it calculated. I don't happen to know if this is June or if this is June because I don't know which way it's moving, but you could use the table to find that out. You'll also notice that if I zoom in, only this middle aperture shows the 2 dithers that I asked for. These other spots only show the original aperture of MIRI. The next change I want to talk about is also in Aladdin. I'm going to choose a different observation. I load the digital sky survey. And now you can see the MIRI imaging aperture for this observation. And what I want to talk about is position angles. I'm going to zoom in a little here. If you come to Aladdin and you get your cursor to turn into this little curly Q here, which takes a little bit of, you can rotate your aperture, and that would show you what you're covering given various position angles. And you can see the position angle down here in blue, but when I let go of the mouse, that disappears. If I come up here and I hit orient ranges and I come back to Aladdin, I see this green circle. The green circle is indicating that I have allowed all orients. If I had selected only a few orients, you would see only this part of the circle that I had selected in my orient requirement. And again, if I rotate this, you can see it gives you a green number. You can see it now says 6.241. It does not update as I move my mouse, but it does update when I let go of the mouse. So, you know, if I liked this position, I could record that number, and then I could move to a different position and record that number. Be aware that just changing your aperture position in Aladdin does not do anything to your observations. If you want to restrict the position angle of your observations, then you need to add a special requirement in the special requirements section. The next 2 topics that I'm going to talk about are here on the proposal information page. So I go back to the form editor. Amaya was talking a lot about multi-observatory proposals. So if you are proposing for multi-observatories, you click multi-observatory. If you're submitting for the JWST Cycle 4 TAC, as she indicated, then JWST is primary. We want to know what other observatory you're going to use, let's say Chandra, and how much time you're requesting from them. Once you fill that in, it asks you to click this box that says we have not submitted a similar coordinator proposal for another observatory's peer review this year. And that means that we want you to only submit one primary proposal to the primary TAC. We don't want you to submit this proposal to the primary Chandra TAC as well. Now, if you are proposing to use JWST and, for example, Chandra, in the Chandra TAC, you would submit your main proposal to the Chandra TAC, and you would click JWST as secondary here in APT. You would tell us which TAC is the primary TAC, and you would put in a proposal number that you were assigned when you submitted your proposal. Now, it's very important that you actually submit this APT file to us before any decisions are made by the primary TAC, because we want to know what parameters and what kind of science you're doing with JWST so that we can provide the primary TAC with any information they may want. And also, this gives us a good way to track multi-observatory proposals and know that your proposal may or may not be coordinated in time with this other observatory. And if you do not submit this proposal to JWST, even when JWST is secondary, that could cause trouble and you might not get your JWST observations. So it sounds like you're submitting two proposals, but you're sort of not. The main proposal is still going to the main TAC, and this is just an APT file containing the JWST observations that you wish to have as secondary supporting observations. The next change I want to talk about is for fields of opportunity. So you'll notice that there is a number of target of opportunity activations button here. If I expand that out, you'll see that all three of these boxes are grayed out, and that's because I haven't defined a target of opportunity observation yet. I have one here, but I have not added the special requirement target of opportunity. When you add that, it will ask you for a response time, and that response time will decide whether or not your proposal is ultra rapid, disruptive, or non-disruptive. So I'm going to put in 5 days, and that should count as a disruptive but not ultra fast. So now if I go back to my proposal information page, you'll see that the disruptive box has been ungrayed out and needs to be filled in. That's why the red X is here. So perhaps I want to actually do 2 activations using the same target of opportunity template. So I would put 2 in the box for 2 activations. What if I wanted to do 2 observations, but I only wanted to activate once? So let me make another one. Now they both have the target of opportunity response time 5 days on them. And if you were doing this, you might want to group them within a certain amount of time. So I'm going to say group the 2 target of opportunity observations within 5 days. Now you have 2 observations. You still have an activation time of 5 days. And when you go back to the proposal information page, the disruptive box is still the only one that's not grayed out. But you wanted these 2 observations to go on 1 activation. Perhaps you were using 2 different instruments to look at the same target. So you would still put in only 1 activation, even though you have 2 target of opportunity observations there. Now I'm going to put this back the way it was. And I'm going to talk about my next change, which is that the visit planner can now schedule out 5 years. We used to be only able to do about 2 years from the beginning of the cycle, but now we can do 5. So you'll see that by default, the time range here is cycle 3 plus a little bit of extra time at the end. But if you were doing a multi-cycle proposal, you might want to know what opportunities there were available in other cycles. So you go up to the visit planner and you just set processing date range. And this will allow you to set processing dates. I'm going to put in 2027 1st of January to 2027, the 1st of March. Okay, so that puts my dates in here. And then I can hit OK. Now it hasn't done any processing yet, and you can tell because the update display button is still red and the dates have not changed. If I click the update display button, then it will start running the visit planner, and it will be running the visit planner over these dates on whichever observations I have chosen. So if I had chosen the entire observation folder, it would be running all of those observations. I just chose one, and so here's where this observation is schedulable during those dates. And if you want to switch back to other dates, you can go back up here to visit update planner and pick a different range. Okay, the last change I'm going to talk about, I don't have a demo for in APT. So I'm going to go back to my slides. And this is wavelength ranges of interest for the multi-object spectroscopy. The idea here is that there will be particular parts of the spectrum that you would be particularly interested in that you would not want to fall into the chip gap, off the chip, maybe onto another spectrum, etc. This slide is showing you what kind of catalog you would be uploading to APT to use the multi-object spectroscopy. The target name is here off the screen, but you can see a position and a deck and a magnitude. The change here is that there are wavelength ranges, start and end for interval 1, 2, 3, 4, and 5. So you can enter up to 5 ranges of interest. And you could label them, for example, as the oxygen 3 line or the H alpha line. And then you could put in the wavelength ranges that describe those features for each target, because of course they would change based on your redshift. So what does this look like in APT? This is the MSA planning tool. And here is the wavelength range setup. So you can tell it that you're interested in which wavelength range and for which catalog, either the primary catalog or your filler catalog. And in this example, we've decided that the wavelength range 1, 2, and 3 is very important for every target in our primary catalog, but only the first wavelength range is important in our filler catalog. And so that will go into the planning and the choosing of the targets and the slits that are open. This is pretty complicated. So there is an article here on this slide that is giving you the link to the information on the I forget what MPT stands for, but it's the planning tool for the MSA, multi-spectroscopic array. And section 7 here is the one that talks about the wavelength range setup. So hopefully that will answer some of your questions that you might have on how to set that up. It occurred to me that you might want to know where to go for help and help desk tickets. This is the Astronomer's Proposal Tool homepage. It's at www.stsci.scientificcommunity/software/astronomers proposal tool-apt. I'm sure that link is somewhere else in the call for proposals. But on this page, you can both download APT as well as get links to the support desk or other knowledge articles.